All right, guys, today we're going to look at graphs of functions, all kinds of different functions in a graph. So hang in there. You got this. You've seen most of this before. Let's do this. First kind of graph we're going to look at are linear functions, or graphs that are lines. Two kinds of equations give you that. One is the famous one, mx plus b, which you know is slope-intercept form, I hope, where b is your y-intercept, m is your slope, and it's going to make a line every time. Notice there's no exponent, or the exponent is 1 on the x. The other kind of line is just f of x equals b. Like you may see f of x equals 3, which means it goes through 3 on the y-axis. The whole graph does. Okay, so you may see that as well. For example, next page says f of x equals 4. Really just says y equals 4, which means y is 4 all the time, which means it's got to go through 4 on the y-axis, and it keeps going like that the entire length of the line. Okay, so everywhere on that line, y is 4. That's all you have to do. Okay, this is one that's in slope-intercept form. Notice there's a 1 as an exponent. You don't see an exponent, which means the y-intercept is -3, and you've done this a long time. The slope is 2, so I'm going to start at the -3, rise 2, run 1, connect the dots, la la la. And you got it. All there is to that. Next are power functions, which means the exponent is not 1 anymore. If you have an even exponent, look at there's an x squared, there's an x to the 4th. Both of them are shaped like a parabola. And that's going to be the case if it's an even power. Both ends are going to go up left and right. And sometimes, depending on what you have with it, if it's just this only, if it's just an x to some power, they're all going to look like that. If they have other x's with them, that's going to change the shape in the middle a little bit. Odd powers, like x cubed, x to the 5th, look what they look like. It's basically a parabola going different ways. Like there's half the parabola going this way, half going this way, half going up, half going down. Okay, that's what powers look like. So when you see this one, x squared minus 2, that's an even power. If you try to figure out how to graph that one, let's pick some points around the origin. Like if I put it in 0, I get -2. If I put it in 1, 1 squared minus 2 is -1. If I put it in -1, you also get -1. So it's looking like 0, -2, 1, -1, -1, -1. And so I know it's a parabola shape because it's a power graph, and so it's going to look just like that. The -2 actually shifted it down too, which we'll learn about very soon. Okay, here's an odd one. And again, so this is an odd root, which means, it's basically half are probably going up, half are probably going down, like we saw in the picture a minute ago. Again, let's pick some points here. Let's go x and y. Maybe choose 0. If you put 0 in for x, you get 3 for y. If you put 1 in for x, you get 4 for y. Let's go -1. -1, you get 2. So let's plot those points and see what we got so far. 0, 3 is up here. 1, 4 is up here. -1, 2 is down there. So you can kind of see how it's going to go. It's going to do this kind of thing right here. And that's what the graph's going to look like. All right, root functions. If you have an even root, like a square root or fourth root, it's one of these. It's going to be half of a sideways parabola. Okay, it's like a parabola going sideways, but it's only half of it. If it's an odd root, like a cube root, 5th root, 7th root, it's kind of like the function we just did the power with that was odd, that had the parabola, half are probably going each direction. This one has half going this way, half going that way, half this way, half that way. So the evens, just half of a sideways parabola. Odds, both halves, but going different directions. Let's look at a couple. This is an even root, which means it's going to be half of a sideways parabola when we get done. But let's go ahead and put some points in here and see what happens. Let's go with 0. If I put 0 in there, I get 2. Be careful what you put in here. I'm going to put a -4 in there because -4 plus 4 is 0, and the square root of 0 is 0. I'm only going to put numbers in that I can get the square root. So I may put a 5 in there for x, because 5 plus 4 is 9. Square root of 9 is 3. So let's plot those three. I got 0, 2, which is here. -4, 0, which is way over here. 5, 3, which is here. And that's the 3 is enough right there. So remember, we know what the shape's going to look like. It's just a matter of where is it. And that's where it's going to be. All right, last thing. Absolute value function. I think it's the last thing. Absolute value function is always a V shape. Looks just like this. If there's nothing inside, obviously it starts at 0, 0, and goes up both directions. Matter of fact, the slope of both these lines is 1. Like it goes over 1, up 1, over 1, up 1, over 1. Same thing over here. Over 1, up 1, over 1, up 1, over 1, up 1. Let's try 1. Okay, so it's absolute value. You know it's going to be a V shape. Let's put some X and Y points here. See what we got. Let's plug 0 in. If I plug 0 in, I get 1. If I plug 1 in, I get 2. If I plug -1 in, I get 0. Let's go one more. Let's put a -2 in there and also get 1. Okay, so 0, 1 here. 1, 2, up here. -1, 0, -2, 1. You can see the V taking shape. It's the same V as was on the last slide, except it's been shifted over 1 to the left. Probably has something to do with that 1 right there. We'll learn that in a couple days. All right, last slide. We're not going to graph any of these, but these are 2 more functions you might see in the assignment tomorrow. Reciprocals, when you have an x on the bottom of a fraction. If it's odd, an odd exponent, you're going to see a curve in the first quadrant and a curve in the third quadrant. And they never touch the axis, by the way. The curves get closer and closer to the x-axis and y-axis, but they never touch or intersect. If it's an even power on the denominator, both curves are on the top because they can't be negative. Greatest integer function is also called a step function, and you can see why right here. Hopefully you've seen that before, but basically it works as though if you put a negative 1.5 in there, it's going to graph the greatest integer less than or equal to 1.5, which means it's going to graph -2. So that's how that kind of works. If we see those, we'll talk about that a lot more in class tomorrow. I'll just show you that in person on the video. So we'll do that then. And that's really it. So can't wait to see you tomorrow. Adios.